going to just explain a little bit more thoroughly about how these vectors are done. We will first of all we can there's a bit of notation to introduce here. If we have a little arrow above something, that's basically saying it's a vector. So that's that bit first. I'm just going to change my color of the pen. So that's a vector, and so is that. So as you can see down here, we've got A and we've got B. Now, let's look at what it says for A when you click on A. So when it's clicked on B at the moment, and you can see BX is 5 and BY is 5. So how would I draw that as a column vector? I would write it like this. So 5, 5. And then we have A. So let's just see if we can find the value for A by clicking on A. I mean, we should be able to see it anyway. It's 10 up and it doesn't go across at all. And, sorry, it's not 10 up. It starts at 5. So A is actually going to be the way of writing a column vector for A. Let's just go over this. Is going to be 0 because there's no X component, and 5 because there is a Y component. So we looked at how to add A and B. We would add so A plus B is equal to 0 over 5. I shouldn't say A. Well, I'm not sure how to phrase it, but 0, 5 maybe plus 5, 5. Okay, so we've got 0 plus 5 is 5. 5 plus 5 is 10. Okay, so and it's saying over here that according to this, that A plus B is equal to C. So let's see what happens now if we show this diagrammatically. If I place the way to add vectors is by placing them head to tail like that, and C is actually the distance from the beginning of A to B. Now, if we look at which is what we've shown, but let's just look at it in a bit more detail, so as we can see what is the dimensions of C. Well, it says the dimensions of C is 5 across, and as you can see, it's 5 across there, and it goes from 5 to 15, so it's 10 up. And so if we wrote it as a vector, a column vector, it would be 5, 10, which is what we get here. So you can also multiply. You can multiply a vector by a scalar, and a scalar is essentially just a number that isn't in physics, or you can think about it as a number that doesn't have a direction. So it wouldn't be written as a column vector. We know what numbers already look like. They're just any old number. So 5, 10, 0.3. You can have a minus number, of course. So you can multiply a vector by a number. You can actually multiply a vector by a vector, but it's not something you do. I don't think you do it until you get until you do degrees. So I don't believe I remember doing it at A level, but I might be wrong. Certainly not at GCSE. So we can multiply them by a number. So if we did 3 times A, then that would be equal to 3 times, then A is 0, 5. And so 0 times 3 is going to be 0. 5 times 3 is going to be 15. So how would that look on here? Well, let's get rid of some of this notation here. I'm going to leave that up there. Just going to get rid of this and this bit down here. And then I'm going to move these around again. So let's move this C over here. And we're going to change A to 3A. That's 3A. Okay, so again, it goes 0 across, and then it goes, 0 across, so because it's a vertical line, and 3 up. So, well, 15 up, 3 lots of 5. So, and it's saying that C is, again, it's now saying that C is equal to 3 times A plus B. If I add that there and put this one down here, and you'll find that it's the same. Definitely have a go at some of these figures, some of these questions. Have a go at this simulation and try and set yourself problems. But what I'll do is in a moment is we'll also have a go at some questions. So we've got, so that's basically that's adding them, multiplying them. So what do we do when we take them away? So I'm going to clear that. I'm going to go to this. So this is saying that A minus B is equal to C. Maybe we can make it slightly more interesting. Let's do A minus 2B is equal to C. Well, there's our resultant vector over here. So how would I minus 2B? What you do, rather than putting it end to end, you actually you would reverse it. So essentially you're going to put it like that, because minus 2b would be 2b but pointing in the opposite direction. So this is 2b, but minus 2b would be where the head goes over there and the tail would go up here. So the way I would actually draw it normally is by reversing the c around. So you point it that way. So let me just draw it with my pen so I can explain what I mean. So minus 2b would be something like that. It doesn't matter where the vectors are, that's why I'm allowed to move these around. But if I want to add them up, that would be my process, how I would do it. So when I get C here, it joins it up like that. So we'll have another go at showing this with a column vector. So I did A minus 2B. So we've got A there and we've got B there. So we're going to do 0, 5 minus, and it's going to be 2 times 5, 5. So 0 minus 10, 10. And that's going to be equal to negative 10. And 5 minus 10, negative 5. So if we have a look, we can see that the height of that is minus 5. It drops from 10 to 5, so it drops or it increases by negative 5 if you like. The change is negative 5 in any case. And I've not quite lined it up properly, but because it's not, so if I line it up so it's a little bit clearer. Oops, that's moved a bit too far. There you go, you can see that's definitely minus 5. And you can see it's actually gone from 5 to 15, and so that's 10 across. So, negative 10, it's gone from the right to the left. So it's minus 10, minus 5. So that's adding and subtracting vectors. Finally, we've got this situation. Let's look at this. And this is saying, so I'll get rid of some of the values here. And what this is now saying is that if you were to add all the vectors together, then it would be equal to 0. Well, that can just be rearranged in a way you would normally rearrange an equation. So A, vector A plus, I've got 2 lots of B this time. 2 vector B. I'm going to say, well, we could say it's equal to negative C, but maybe it's better to, actually, yeah, okay, let's just say it's equal to negative c. Now, negative c would be where the head of it would actually be here, and there'd be no tail there. So we've got our 2b and we've got our 2a. We're going to add them together properly now. They're currently not properly adding together. I'm doing it as if they're taken away. So we're going to do head to tail again. And then this is going to be like that. Now, actually, maybe their way of doing it is quite a good way to do it as well, actually. This is what you call a triangle of vectors. When you do if you do A-level physics, they call it triangle of forces, but that's only because they're using force as a vector. Essentially, if all the vectors adding together, so I like their way of doing it better actually now. I see why they did it that way. Yeah, so basically what it's saying is that all these three vectors, when you add them together, is equal to 0, and the way that you can tell that is because, let's say we started there, and when we look at the resultant vector, we want to say we would draw an arrow from the beginning to the end of the resultant, right? So in other words, when I was working out the resultant of a plus 2b, I would essentially go from the beginning to the end, and that purple line is my resultant vector. But because we're now doing all of them adding together, and we're saying that it's equal to 0, then the beginning and the end is in the same place. In other words, the distance between the beginning and the end is 0. So you're gonna get that sort of shape. You can actually change the values of the vectors themselves, which is quite handy. I didn't know you could do that. Yeah, have a little play with this. Oh, that's quite useful. I don't. Yeah. Okay. Have a little play with this yourselves, and then set yourself some problems. Well, let's have a go at some questions now. So I'll get rid of that ink on the screen. I'm just going to open this up and see if we've got some adding and taking away. So on the axes below, draw the vectors. Okay, so we're going drawing some vectors, 1, 3, from A. Okay, so it just means draw a line where, let me get another, get an arrow here. Basically, a vector is always going to be like an arrow like that, and that arrow can be drawn as. In fact, I'll just do the answer to the first one, then we can discuss it. So, 1, 3. So what we want is something that's 1 across and 3 up, and we're going to do it from A. So it's that, because it's 1 across and 3 up. From B, it's going to be 2 across and -1 down. So that's 2 across, and it's going to go down by 1. Okay, and then we've got -4, so it's actually going to go left by 4. Okay, but then it's also going to go down by 5. That's 1, 2, 3, 4. It's going to go down to 1, isn't it? So -4, it's gone across by 4. It's gone down by 5. So those are my 3 vectors for that one. Okay. I'll just go through these and just make sure that you pause the video before you have a go at them. So let's rub those out. And I want to get a mouse. Have a go another one. Given the vectors, A is 2, 3, or 2 over 3, however you say it. B is 1, 5. Draw and label the vectors from the origin in the question in the axes below. So we can do these in 2 different ways. Let's do them in both ways so as we can get familiar with how this is done. Let's do it the column way first. So I'll just scroll up again for a moment. Maybe if I use F11. Okay, cool. So I've got a bit more space now. So 2a would be just going to be 2 times 2 and then 2 times 3. So it's going to be, so 2a is going to be 4, 6. A plus b is going to be, we're going to add them together. I'm doing the column vector way now rather than a diagrammatic way, but you're going to see that they both will give you the same answer. So a plus b is going to equal to 2, 3 plus 1, 5. So that's going to be equal to 3, 8. And then 4a minus 2b, well, let's do 4a first. That's going to be, so that's going to be 8. And then the 3 times 4 is going to be 12. You see how it's not the same as a fraction, is it? Because if it was a fraction at this point, I would just simplify it and we'd end up back to where we started, 2 over 3. So it's going to be 8 over 12 and then minus 2b, which is going to be minus 2 over 10, or 210. And then I could actually see that 8 minus 2 is 6, 12 minus 10. And this really this isn't how fractions work at all, right? That's not how you minus fractions at all. We always have to have a common denominator. 12 minus 10 is 2. So that's the column vector way of doing it. And now let's do it the diagrammatic way. Okay, so I'm going to get some line tools here. And let's draw A. It doesn't matter where I draw it, but it's got to be, I'm going to do it up at the top here. So we want to get 2 across. So maybe start from there to there and make sure we go 3 up. So let's do, so that would be A. Actually, I don't want to do it there. I'm going to start down at the bottom. I want to start here, actually. So we'll go 2 across. It's going to go from there to there. But it's going to go 3 up. So that's my A. Okay. Now it's 2A, so we can just, basically it's like A plus A. So again, 2 up and 3 across. Now you can see that resultant vector is 4 across and 6 up, which is what we found when we did that. Okay, let's use a different color now. So we've got A plus B, or let's just use this A down here, and we'll say B is 1 and then 5, so it's going to be 1 across and 5 up. 1, 2, 3, 5. Okay, so we'll do the resultant this time in, let's do it in a green. We'll start from here, and that's my resultant. And you can see that is 3 across, and it goes up to 8, which is what we've got there too. All right, I'm going to just rub out those ones so we've got a bit more space to play with for the final one. Okay, so the final one, we've got 4a plus minus 2b. So we'll do our a again, which is 2 across, 3 up. We can't really do that actually, can we? So because what we would have to do is do it again. That gives me, and then we're going to run out of space. So we can't actually do this one diagrammatically. But I could sort of do it by cheating, I suppose. So let's just change the scale of this. So I'm just going to get my pen tool, and we'll say that this is 2, 4, 6, 8, 10, 12, 14, 16. And this is 2, 4, 6, 8, 10, 12, 14, 16. Hopefully we've got enough space now. Didn't actually think too carefully about this, but hopefully I'll have enough space. So we want to do, so this time A is 2 across, which is just that, and then 3 up. So that is A. And then we're doing 4 lots of A, aren't we? So we're going to do it again. which will take us up to there. And then again, which will take us up to here. And again, which will take us up to there. So I said that 4a was 8, 12, 8 across, 12 up, so that makes sense. And then we're going to minus 2, 10. So that's going to be negative 2 down. Sorry, negative 2 to the left. So, 2 to the left, and then 10 down. Let's choose a different color. Well, actually, I'm going to do B, do it properly. So negative. So we'll do minus B, then minus B again. So 1 across. B is 1 across, and 5 down. So 1, 2, 3, 4. Oh wait, I've used a different scale, haven't I? Okay, so hang on a second. Let's just do that again. So it's 1 to the left, which is just going to be. Try that again. It's going to be there. It's halfway across, and 5 down. Well, that is 2 down. So that is 4 down. So that's going to be 5 right there, actually. Should be going from that point there. And we're going to do that again. So it's 1 across, which means it's going to go to the 6th line, and it's going to go 5 down. So that's 1 down, 2, 3, 4, 5. Okay. And then we're going to do the resultant vector. We'll do that in green again. No, not in green. Let's do it in red. So the resultant is from the beginning to the end, which is this one here. And you can see that's 6 across and 2 up, which is what we've got. Okay, so that is how to add vectors and take them away and multiply them. And it's combining the idea of using a diagram with using a column vector. So I hope that was handy. I hope that was useful. And I'll have a go at the rest of the questions. The answers are on the right-hand side. And if you are watching this online, just contact me and I can give you the access to these questions. Cheers. Bye.